Okay, guys, let's talk about stoichiometry, limiting reactant, and yield. We're going to talk about what theoretical yield is and how to calculate your percent yield. So I have a sample question here. It says a chemist produces SBF5 by reacting SbCl5 with HF according to this equation. So it says if he has 182 grams of this stuff and 37 grams of this stuff, what's the limiting reactant? So see how the question gives us two different amounts of reactants and asks which one is the limiting reactant. So whenever it's a limiting reactant question, we know we're going to have to do two different stoichiometry problems. Okay, so let's go ahead and start with our first reactant here, which is our 182 grams of our SbCl5. Okay. And we're going to figure out how much product we could make with this amount of reactant. And if you have two products, it doesn't matter which product you choose to do your stoichiometry problem for. It doesn't matter which product you solve for in order to figure out the limiting reactant, as long as you're consistent with both of your stoichiometry calculations and you pick the same product to compare side by side. So we're just going to pick this first one, and that will help us to solve the other problems later on, okay? So I start out with grams. If you ever start out with grams, your first step is to take those grams and turn them into moles. So because I have grams here, I'm going to put grams here so that they cancel out, and I'm going to change it into moles of SbCl5. Now I'm not even going to fill in my numbers yet. I'm just going to fill in all my units and substances. So now that I have moles SbCl5, I know that has to go on bottom, so it'll cancel out. And then I'm going to go to moles of what I'm looking for. And again, we got to go to one of these products. And I said, let's go to this first one because that will make doesn't matter which one you do. But later on, I'm going to ask you about SbF5. Okay. And now that I'm moles SbF5, now if I'm just looking for limiting reactant, I can just stop there at moles. I don't necessarily have to go to grams. So we can just stop there at moles. Now we're going to figure out where our mole ratio is. And if you remember, wherever your mole ratio is, that's where you have moles over moles. And I like to put a little cloud around it to remind me, hey, this is a mole ratio. This is the only place you should have a different substance on the top and bottom. Everywhere else, your substance can be the same. This is the only place you can change substances. And this is where you look at your balanced chemical equation to find your coefficients. So SbF5 has nothing in front of it, so that's a 1. SbCl5 has nothing in front of it, so that's also a 1. Now, everywhere else you see the word mole, you're going to put a 1. And G for grams tells me to go to the periodic table and calculate the molar mass. So I went ahead and did that, and for the molar mass, I got 299.01, okay, for the molar mass of that compound. And I'm going to cancel out all my units. So now when I go and put this in my calculator, I'm going to do 182 divided by 299.01. Everything else is a 1 in our problem, so we can just do that. And I got 0.608675, which, if I'm rounding to 3 sig figs, would be 0.60, and then this would bump that up to a 9. Okay, and that would be moles of SbF5. Okay, so that's how much SbF5 I could make with 182 grams of this stuff. Now, let's do the same thing with our other reactant. So I have my 37.0 grams of HF, and we're going to do the same thing, try to get to moles of SbF5, and we'll compare the two side by side. And whichever is smallest will kind of tell us what our limiting reactant is. So because I have grams of HF here, I know I need grams of HF here, so they cancel out. I'm going to change it to moles of HF. And then I'm going to go from moles of HF to moles of what I'm looking for, which is, again, that SbF5. We're going to compare side by side which one would make more or less SbF5. So this is my mole ratio, where I have moles over moles. That's where I look at my balanced chemical equation to find the coefficients. So SbF5 has nothing in front of it, so that's a 1. HF has a 5 in front of it. Everywhere else I see the word mole, I'm going to put a 1. And G for grams tells me to go to the periodic table. So I'm going to go to the periodic table and find the molar mass of HF. And when I add it up, I got 20.008. Okay? And then cancel all these units. Now I'm going to go ahead and put that in my calculator. So I'm going to go 37 divided by 20.008, enter, and then I'm also going to divide by 5, enter, and that's what I get. So I've got 0.36985, dot, 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 dot. If I want to round to 3 sig figs, that's going to be 0.3. Technically, this 8 would bump that up, so it would be 3.70 moles of SBF5. Okay? All right, so now I have these two different numbers, and I'm going to compare them side by side. So you look at these two, and you say, which one is smaller? The smaller answer is this one. Okay, so that tells me this smaller answer is my theoretical yield, and it tells me that HF is my limiting reactant. Okay, so remember, your limiting reactant. So the answer to my question, what is limiting reactant? Limiting reactant is HF. Remember, your limiting reactant has to be a reactant. It has to be one of your two reactants. So many people make the mistake of saying, oh, this is smaller, so my limiting reactant is SBF5. That should be an F. That is embarrassing. SBF5. No, that's not even a reactant. So your limiting reactant is either this or this. Because your smaller answer came from your HF, that makes HF your limiting reactant. And your smaller answer itself is your theoretical yield. Now, your bigger answer, remember, it's nothing. It's garbage. It's poop. We don't care about it. It tells us nothing. This does not tell us anything. So we have to go with our smaller answer. Okay? Now, the next question says, what is the theoretical yield of SBF5? But it's asking in grams. So we figured out our theoretical of SBF5, but this is in moles. So we would have to take that and convert it to grams. So let's go ahead and do that. So our 0.370 moles of SBF5, we're going to go ahead and convert it to grams. So because you have moles SBF5 here, we're going to change it to grams SBF5. Just one more step. So 1 mole is equal to the molar mass in grams. So G for grams tells me to go to the periodic table. And when I do that and I add up its molar mass, I get 216.76 grams. Okay? All right, so then I'm going to put that in my calculator. I'm going to go 0.370 times 216.76. And that's what I get, 80.22012. So if I'm going to round that to 3 sig figs, it's going to give me 80.2 grams. SBF5. So that would be my theoretical yield in grams. Okay? So your theoretical yield is the smaller answer you get. Now, the third thing that it's going to ask here in this problem is, okay, if you do this experiment and you know, okay, I'm supposed to get 80.2 grams. That's my theoretical yield. But I do the experiment, I only get 59.3 grams. This is how much was actually produced. What's the percent yield? So if you remember, the percent yield is equal to your actual over your theoretical times 100. Okay, your actual over your theoretical times 100. So let's do our actual, which is 59.3 grams, over, this is a 3. Our theoretical, which we calculated, was 80.2 grams. That's how much we technically should have produced, times 100. So we would do that, 59.3 divided by 80.2 times 100, and I got 73.940, dot, 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 dot. Okay, so this would be, if I'm going to round it to 3 sig figs, 73.9%. That would be your percent yield. Now, in a perfect world, every experiment you do, you'd get 100% yield. But most of the time, you don't make as much as you projected that you would make. So something like a 73.9% yield makes sense. So technically your percent yield should not be over 100. However, we've done an experiment this year in the lab where some of you guys did get over 100%, and most of the time that's because your sample was contaminated or it wasn't dried properly. But theoretically, technically, your percent yield should never be over 100. In a perfect world, it would be exactly 100%. Anyway, just to kind of clarify that. Anyway, go ahead and do the practice problems, and as always, let me know if you have any questions.